Hello guys, welcome to the DMS Online School. In today's video, I'm going to teach you a chemistry lesson on a very important topic in chemistry known as chemical formula. So it is very important as a pupil that is learning chemistry that you know how to write a chemical formula of different compounds which exist. All right, because without knowing the chemical formula of different compounds which exist, it will be very, very hard for you to understand chemistry and actually write chemical equations. Okay, so it is very important that this lesson that I'm going to teach you will be able to impart a skill in you on how to write the chemical formula of compounds. So by the end of this lesson, I believe you will be able to write the chemical formula of compounds. So the lesson is on writing the chemical formula of compounds. Okay, so we'll be looking at so I always give a definition whenever I'm teaching because a definition harbors or contains what we call the concept of that particular topic. So whenever you are studying, whenever you are learning something, it is very important that you understand any definitions that are provided in that particular concept which we are learning. So I'm going to define what a chemical formula is so that out of that definition, you will be able to understand what a chemical formula is. So, a chemical formula, this is how I define a chemical formula. So, I say a chemical formula is a short way of writing the names of compounds using the chemical symbols of elements on the periodic table. So that's how I define a chemical formula to be. So a chemical formula is a short way of writing the names of compounds using the chemical symbols of elements on the periodic table. So what that means is e.g. I can give you the name of a compound like this, e.g. we have the name of a compound calcium chloride. This is a compound. A compound is a substance that is made up of two or more elements chemically combined together. So this one is a compound because it is made up of two or more elements. In this case, we have two elements, which is calcium and chlorine combined together. And when two or more elements combine together chemically, they form what we call a compound. So this one is a compound called calcium chloride. So this calcium chloride is written in four ways, calcium and then chloride. However, we can write this one in terms of chemical formula, just using the symbol of calcium that is found on the periodic table and the symbol of chlorine which is found on the periodic table. In this case, calcium chloride can is written as the symbol for calcium is capital M, and then capital C and small letter A, and then the symbol for chloride, which is chlorine, is capital L and small letter capital. Sorry, here let me write it properly. Here it's actually capital C and small letter L and a 2 down here. Now, this is calcium chloride. It is a short word. When you look at calcium, it is a long word. But when you look at this one, calcium chloride, it is a short word. Hence the definition. A chemical formula is a short way of writing the names of compounds using the chemical symbols of elements on the periodic table. So these symbols I've used here, they are gotten from the periodic table. Now, in this one, you might be wondering where is the two coming from there? And that is the skill you are going to acquire today. And by the end of this lesson, you will be able to understand even where these two came from. So pay much particular attention as I continue explaining. All right. So now, when you are writing chemical formula, we have seen that the following are the requirements for writing chemical formula. Number one, you need to know what we call the chemical symbol. These chemical symbols, where do you get them? From the periodic table. So this comes from periodic table. So you need to get familiar with a periodic table. Then what do you also need? You need to know what we call valence electrons. Now, what are valence electrons? Valence electrons are number of electrons which a metallic atom loses to become stable. Okay? So there are two definitions, or I can define it in one way. I can say this is the number of electrons that an atom loses or gains or shares when or for it to become stable. Yeah, I'll put it that way. For it to become stable. Yeah, so that is what it is. So valence electrons is just the number of electrons that an atom loses, gains, or shares for it to become stable. So this is a very important concept that you need to understand. So these definitions. So you must understand that metallic atoms loses electrons to become stable. So metallic atoms loses electrons to become stable. Then another concept you need to know is non-metallic atoms gains or shares electrons for them to become for them to to become stable. So that's what then happens. So these concepts that I'm giving you must be understood and must be kept in your mind, in your brain, as you are writing chemical formula of elements. So, having given you this concept, it is very, very important because these valence electrons, as much as you see it to be simple like this, exam questions come in a way they may ask you to just define valence electrons. So this definition, you must understand it. So this is the number of electrons that an atom loses or gains or shares for it to become stable. Now, metallic atoms loses electrons to become stable, while non-metallic atoms gain or shares electrons for them to become stable. All right. So having this concept here, I am going to give you examples on how to write the chemical formula. So let's look at the examples. So this example says, write the chemical formula of the following, and we have magnesium chloride, B, we have sodium chloride, then C, we have maybe calcium chloride, then D, we have maybe sodium oxide, then A, B, C, D, E, then we have, let me just put maybe magnesium oxide. So we have been provided with these uh, chemical or compounds: magnesium chloride, sodium chloride, calcium chloride, sodium oxide, magnesium oxide. Okay. So this chloride is chlorine atom that has changed into chloride after combining with another element. So whenever nanometals combine with the metals, their name changes. So like magnesium goes, when it reacts with the chlorine, chlorine becomes chloride. Also when, like here, sodium reacts with oxygen, oxygen changes to oxide. So this is sodium oxide. Magnesium oxide, meaning magnesium reacted with the oxygen. These are some of the concepts that you need also to understand. Now, here we are. We have magnesium chloride, which they need us to write its chemical formula. Now, when you're writing the chemical formula, we said, what are we needed to know? We need to know the symbol for magnesium and the chlorine. From where? From the periodic table. So when we go for solutions, the symbol for magnesium from the periodic table, this magnesium here, its symbol is capital M, like that, as small letter G. And chlorine, its symbol is capital L and small letter, I mean capital C and small letter L. Now, once you write that, the next thing is to find the valence. So how do you know the valence? When you go on the periodic table, magnesium is going to be like this with a 12 here and a 24 here. So it is this 12 that we use. That 12 there represents atomic number or number of electrons in magnesium atom. Now, these electrons exist in what we call shells. Okay? So there are many shells in this magnesium atom. Now, how many electrons are supposed to be in shell number 1, shell number 2, shell number 3, shell number 4, and so forth and so on? So you must understand that in shell number 1, how many electrons are supposed to be there for that shell to be full? Only 2. Now, if you have 12 electrons in magnesium, you get 2, they sit in the first shell. You remain with what? 10. Okay? So you do like this, 10. Now, out of that 10 electrons you have remained, now those are supposed to go in shell number 2. So shell number 2, according to the rule, is supposed to have 8 electrons to be stable. So from 10, you get 8, you put in shell number 2. You remain with what? You remain with the 2. Now, you go to shell number 3. Shell number 3 is supposed to have 8 or 18 for it to be stable. Now, since you have remained with only 2 electrons, you put 2 electrons in that. So meaning, these 12 electrons in magnesium, they sit in shell number 1, occupies 2 electrons or holds 2 electrons. Shell number 3 holds 8 electrons, and then shell number 3 holds only 2 electrons. Now, this shell is supposed to have 8 or 18. Now, since it doesn't have 8 or 18, this shell is considered to be unstable. And when magnesium reacts with it, chlorine to form a compound, magnesium always loses these electrons so that it becomes stable. Just as we said, like metallic atoms lose electrons. So magnesium will lose these 2 electrons so that at least it should have a last shell which is stable. So when it loses this, it will remain with this shell with 2 and then with this shell with the 8. So this is considered to be stable. A last shell must always contain the maximum number of electrons required in there. That's why this doesn't have, so it should lose those electrons so that we remain with this as the last shell because it has the maximum number of electrons required. Now, magnesium lost 2 electrons. Those 2 electrons becomes the valence for magnesium. So the valence for magnesium is 2. So that valence, we write it on top of magnesium as a power here as the 2. That's how we write it. Now we have done away with magnesium, we come to chlorine. Chlorine on the periodic table, it is written as capital C and small letter L. Here you find there's 17. Here you find 35.5. Now what is important is this 17. 17 represents the number of electrons in that chlorine atom. Now, just as I said here, the first shell is supposed to have 2 electrons for it to be stable. Now, out of 17, if you remove 2, you remain with what? 15. So, in the second shell, it's supposed to be 8. So, you have removed 8 from 15, you have put there, you remain with what? 7. So you do like this. The third shell is supposed to have 8. Now you have only remained with 7. So you put 7 there. Now, this shell, which is the last shell, since it doesn't have the required number of electrons, which I said 8 or 18, then since chlorine is a nanometal, then it has to gain how many more electrons to make this to be 8, just 1. So therefore, chlorine atom gains 1 when it reacts with magnesium for it to become stable. So when it gains 1, it will be 2, 8, 8. So the last shell since has 8, then it is stable. Now, how many more electrons were gained to get 8 from here? It is 1. Therefore, that number of electrons which were gained, which is 1, becomes the valence electron for chlorine. So you know 1 is the valence, so you write it here as a power. Then after that, you have to swap. This one should come here, and then these two should come here. So that now it will be like this. Magnesium with this one down here, and then chlorine like that with these two down there. You see? Now, from there, 1 is never indicated in the chemical formula, is always removed. So this one becomes now capital M, small letter G. 1 is removed, then you remain with C, then L, then this 2 is written now here. This is small letter L. Okay, if you write capital L like this, you get it wrong. Always follow what is provided. So this now becomes magnesium chloride as the chemical formula. So you have seen where the 2 has come from. Okay? Now, this now is very important because it is telling us that in magnesium chloride is formed from 1 atom of magnesium combined with 2 atoms of chlorine. So in magnesium chloride, you have 1 atom of magnesium combined with 2 atoms of chlorine. So this one is the chemical formula. So when you see this one is long, this one is short. So we go to B. B, we have sodium chloride. So again, the symbol for sodium on the periodic table is capital N, small letter A. Then chlorine, we have already written Cl. I said it is capital C, small letter L. Now, we need to know the valence. Of course, the valence for chlorine, it is now 1. So put 1 there. Now, we need to know the valence for sodium. So sodium, when we come on the periodic table, it is written as N, A, then here 11, then here 23. It means sodium has 11 electrons. So in the first shell, it should have 2. So from 11, when you remove 2, you put in the first shell, you remain with 9. So in the second shell, you should have 8. 8, you put there. So from the 9, when you remove 8, you remain with 1. Then the third shell is supposed to have 8 or 18. Now you have just remained with 1, so you put 1 there. Now, this sodium atom is not stable because it has 1 electron in the last shell. The last shell should have the required number of electrons for the atom to be stable. The required number of electrons in this last shell, shell number 3 here, was supposed to be 8 or 18. Now, because it is not that 8 or 18, this shell is not stable. So when sodium reacts with chlorine to form sodium chloride, sodium always loses that one because the last shell is not stable, must lose, so that we remain with this shell which is stable. So it will lose this electron, so that now sodium will be 2, 8. Okay? So now that way sodium is stable, so that electron has been lost. Now, since sodium loses 1 electron, the valence for sodium is 1. And that one, we write it as a power somewhere here. Then after that, we cross this one comes here, then this one comes there. Then we say equals, There is a sodium with a 1 here, and then chlorine with a 1 there. Now I said 1 is never indicated, so this one remains sodium like that, then chlorine like that. So it means this is the chemical formula for sodium chloride, meaning that in sodium chloride, one atom of sodium combined with one atom of chlorine to form sodium chloride. Okay. So let's look at C. C, we have calcium chloride. So when we go on the periodic table, we need to know the symbol for calcium. In this case, the symbol for calcium is capital C, small letter A, and then chlorine, we already see that it is capital C, small letter L, and the valence here, we have seen that it is 1. Now, calcium is written as follows: Ca, then here 20, then here 40. This means that the calcium has 20 electrons. Now, in the first shell, it should have 2. So out of 20, when you remove 2, you put in the first shell, you remain with the 18. So in the second shell, you should have how many? You should have 8. So 8 you put there. Out of 18, you remove 8, you remain with the 10. So shell number 3 is supposed to have 8 or 18. So we get 8, we put here, because out of 10 we cannot get 18. We can only get 8. So we get 8, we put there, then we remain with the 2. Then we go to shell number 4. Now this shell number 4 is supposed to have either 18 or 8 or 32 to be stable. Now we only have 2, so we put a 2 there. Now that shell is not stable because it has only 2. So shell number 4 is not stable because it only has 2. Because the last shell is not stable, therefore calcium atom is not stable. So it has to lose those 2 electrons when it reacts with the chloride. So when it loses those 2 electrons, it remains with 2, 8, 8. So the last shell now has 8, so calcium atom becomes stable. So since it loses 2, the valence becomes 2. So you put 2 as a power there. Then you cross the 2, comes here, then the 1 comes there. So meaning you write it like calcium with a 1 here, then chlorine with a 2 here. Now remember I said that 1 is never written, so it will be like calcium, then the 2 there. So this is where the 2 comes from. So this is the symbol chemical formula for calcium chloride, and then here we read it as calcium. 1 calcium atom combines with 2 atoms of chlorine to form calcium chloride. Okay. Then we go to C. So let's come to us to D. So D, we have sodium oxide. So the symbol for sodium, we said it is capital N, small letter A. Then oxide is oxygen. Whenever oxygen reacts with another element, the name changes to oxide. So the symbol for oxygen on the periodic table is capital O, like that. Now, sodium, we have seen that the valence is 1. How about for oxygen? So oxygen, when you go on the periodic table, it will be like this. Here you have 8, here you have 16, which means that the first shell should have 2 electrons. So from 8, when you remove 2, you remain with the 6. Now the second shell should have 8. Now you have only remained with 6, so you put 6 there. Now this second shell has 6 instead of 8. So this oxygen atom is not stable. So when oxygen reacts with the sodium chloride, it will need 2 more for this one to become stable because oxygen is a nanometal. So it has to gain 2 more electrons to make this 6, 8 so that it now becomes stable. So it will be like 2 and 8. So that this last shell, instead of it being 6, it will become now 8. So meaning since it has gained 2, oxygen atom has a valence of 2. So you put a 2 here. Then we swap the 2 comes here, then the 1 comes here. So that it goes like sodium, this 2 comes here, then the oxygen with it, this 1 comes here. Then I said the 1 is never indicated, so this one will be sodium with the 2 there and oxygen like that. So this one becomes the chemical formula for sodium oxide, meaning that 2 atoms of sodium combine with 1 atom of oxygen to form sodium chloride. Then D, we have magnesium. We said magnesium, the symbol was this here, we already indicated, and the valence was 2. Then oxygen also like that. The valence is this one, found it as 2. So also we can swap, this one comes there, this one goes there, so that it becomes magnesium with a 2 here, then oxygen also with a 2 here. Now 2 and 2 into 2, 1, 2 into 2, 1. So this one reduces technically to magnesium 1, then oxide 1. So whenever you have numbers that are common, you can divide, you can reduce them. So like here we had 2 into 2, 1, 2 into 2, 1. So you get to that one. Now ones are never indicated, so you have just magnesium like that and oxygen like that. So this is the magnesium oxide. Okay. So this one can be read as 1 atom of magnesium reacting with 1 atom of oxygen to form magnesium oxide. Okay. So well, we have come to the end of this chemistry lesson. I hope by now I have imparted in you a skill or knowledge that is required for you to write chemical formula of compounds. Thank you very much. Thank you very much for watching. For now, I have come to the end of the chemistry lesson. See you in the next lesson. Bye bye.